Hey guys, so last lesson we learned how to write the equations for linear relations. Today we're going to be going over how to graph those linear relations. So this is lesson 5.2, graphing linear relations. We're going to start with just a couple definitions. So a linear relation is a relation with a constant rate of change. We talked about that in the previous lesson when we were looking at like tables and stuff like that, and showing that in a linear relation, the rate of change for your x values and the rate of change for your y values has to be constant. And then when you graph it, it will make a straight line. We can then read the graph using either interpolation or extrapolation. So when we interpolate, that's when we estimate a value between known values. And then extrapolate is when we estimate a value beyond the known values. So for example, if you look at this graph here that has minutes versus meters or distance, it says how long does it take to go 5 meters? And so if we were to try and figure that out, we would just kind of estimate where 5 meters is on the y-axis, go over until we hit kind of roughly where this line would be, and then down to the y-axis. And so we would be able to estimate how long it would take to go 5 meters using interpolation. Because this value that we are estimating is between two known values. On the other hand, when it says how far does he or she travel in 40 minutes, 40 minutes is beyond the information that we've been given. This graph only goes up to 25 minutes. And so in order to predict that, we would be estimating beyond where this graph ends, beyond our known values. And so to guess that, it would be extrapolation. So how do we actually create a graph? That's kind of the important thing of this lesson. And so our steps to graphing. Step one, if you're not given the linear equation, you need to write the linear equation, which again we learned about the other day. Then you need to plot your b value. And so if you remember, your b value is just your y-intercept, so that'll go on your y-axis. And then from that y-intercept, you will rise and run to your next point. So you're going to use your rate of change to find the next point. And then you'll just do that 1 or 2 more times until you have enough points that you can connect them with a straight line. So let's look at an example of how we would do this. I've started with the example, a balloon is released from a height of 2 meters. It then floats upwards by 5 meters every 3 minutes. So the first thing that we have to do, step one, is just write the linear equation that represents this scenario. In order to do that, you might want to identify your independent and dependent variables, as well as your y-intercept and your rate of change. So the two things that we're comparing here are height and time. The height of like 5 meters, the time that's going by. Time is always independent, and then dependent would be the height. The y-intercept, that is the initial amount. So what does this height start at when time is 0? So our dependent variable starts at 2 meters when our independent, when the time is 0. So that is going to be our 2 meters. And then the rate of change is how much it is going up by. So it goes up by 5 meters every 3 minutes. So the rate of change, remember our rate of change is a change in y over a change in x. So our rate of change, our change in height, which is our y value, over our change in time, which is our x value. So 5 meters every 3 minutes is our rate of change. So that means our equation is y equals our rate of change x plus our initial value of +2. You could also, if you wanted to, do it as like height is 5/3 time +2. Doesn't really matter what variables you use. Okay, now let's look at how to actually graph this. Okay, so I've got my graph sketched out here. I've got my time in minutes on the x-axis, and then I have my height in meters on the y-axis. And I've gone up by ones on both axes, so this one I haven't actually written in every other one. But you can kind of choose whatever scale makes sense for the question. I then start by plotting my y-intercept, which we have identified as our 2 meters. Then we are going to use our rate of change. So our slope, which is a rise over run, is 5/3. So from this point, I am going to go up by 5 and over 3. So 1, 2, 3, 4, up 5 and over 1, 2, 3 will bring me to roughly there. And then from that point, I'm going to go up 1, 2, 3, 4, 5 and over 3. Okay, and then we just connect it with a line. Obviously, if this was done on graph paper, it would be much easier and you would get a straight line, but I don't have graph paper with me, so best I can do. But that's it, that's what it would look like. Okay, the last thing I want to talk about is how to figure out what your rate of change is if you're not given a table or a graph. All you're given is 2 coordinates. So just a reminder, our slope or our rate of change is a change in y over a change in x. We can also write that as y2 minus y1 over x2 minus x1. That essentially means the same thing. A change in y is just the second y minus the first y, and a change in x is the second x minus the first x. So we'll start with our first 2 xy coordinates. We'll call one coordinate number 1, the other coordinate number 2. And then we just start plugging in our values into this. So this y would be y2, which is from the second coordinate, and this would be y1, x2, and x1. So let's look at what an example of this would look like. Okay, so I've given you the coordinate 4, -3, and then -6, 2. So we'll plug this into our equation. So our rate of change is y2 minus y1 over x2 minus x1. And I'm going to call this coordinate number 1 and this coordinate number 2. Remember, they are xy coordinates. So y2 is just going to be 2. And then y1 is -3. So 2 take away -3. And then on the bottom, my x2, which is -6, take away my x1, which is 4. And then 2 take away -3 is 5. -6 take away 4 is -10. Oh, and I'm not even showing you what I'm doing anymore. There we go. And then we just have to simplify this fraction. So it would end up as -1/2. Both the top and the bottom are divisible by 5, so I've done that. And then I always like to write, if I have a negative sign, I always like to write it on the top. It doesn't really matter where it is. You could have 1 over -2 means the same thing. But I do like to always write it on the top. It's a little more mathematically correct. Anyway, that's it. That's how you would solve. That's it for today. Let me know if you have any questions.